agenda. So we'll be looking at like what did LLMs fundamentally change, right? How did it change the whole landscape? We'll quickly look into that part so that it builds that understanding that what this will help in doing is when we discuss LLMs, it will help you to understand like what actually are we doing. So then the next part that we'll cover today is like how do LLMs work end to end, like what they do, the underlying mechanism, like what is tokenization, what is vectorization, what is positional encoding, attention, then how does feed forward neural network comes in, and then finally how does it predicts the output, right? So we'll take a look at all of this and we'll do it in two passes. Okay. First pass, we'll just look at what it does, right? So what it means is like we'll understand what actually will it do in all of these phases. And then in the second pass, what we will do is underlying algorithms and like how, technically what it does or like programmatically what it does. We'll look into that. Okay. Mechanics. Yeah. So let's get started. So the first thing is like today's class is like imagination heavy. You have to imagine a lot, right? Like last class was mathematics heavy. Today is like imagination heavy. You have to imagine a lot of things like what's going on. Okay. So first, let's go back to like the era in 2019 or not, right? So what used to happen is like if let's say if you have written some code, right? You run it, it crashes. So what we used to do is we never took the whole code base or the code file and pasted into Google, right? What the workflow back then, what it looked like is like you get an error or you get an crash, you take that crash and paste that into Google, right? So now think about it, like why did you not ever paste the code itself, right? Go back and think that you might be doing this only, right? You took the error and then what you do was you pasted the error code into Google. Okay. So we were thinking about this scenario, Manoj, that in 2019, what used to happen is like we used to take the error code and paste it, not the whole code, right? Why did we used to do that? Because Google was a search engine. All it could do was like find pages that contained the same words as your query, right? It was a search engine. So what we were hoping is like whatever the words my error has, Google might have some articles which can have the same error, right? It never gave you a full-fledged answer that, hey, this is the code, this is the error, what is wrong in your code. What we used to do is we used to do a search that this is the error, 10 articles Google will show, and then we'll go through all those 10 articles and then try to figure out, hey, what is wrong, right? So what did Google was doing over there was it did not have a capability to understand code. What it was doing was keyword matching, right? And we all used to do the same thing, like type in Google, get articles which had the same keywords, and then try to go through those articles to understand. It didn't read your error. It did not understand your error, nothing. It had no understanding of your code. It had no understanding of your error. It was just doing a semantic match. It just hoped someone else had typed those same characters before, right? So try to understand this. No under the code previously, we used to Google errors, but it had not at all any understanding of the code. It was just doing a search. Okay, just the search, and that too not semantic search. It was a keyword search. Semantic search means that at least it understands some concept, but keyword search means like it will match character to character. So in 2019 and pre LLM era, we just had the capability to do keyword search. Right now, what LLM changed? Right now, let's say in today's day, if you hit the same kind of bug which I was talking about, right? What do you generally do? You paste the whole code, right? Sometimes you don't even paste the error, you just paste the code and say find the bug in it, right? And LLM is able to do it, right? So what has changed from 2019 to 2026 is the machine isn't searching anymore, it's reading, right? It's understanding at your code and it's looking at your code and understanding what it is supposed to do, right? So what has changed between 2019 and 26? We solved a problem in machine learning that had been open for decades. We figured out how to make machines understand the language instead of just matching it, right? So what capability we introduced is now don't just match the keywords. You have an understanding of the code and then answer based on that. And one more point to note over here is, so these algorithms were researched on from quite long, right? But we didn't have the compute to run these algorithms. So with cloud computing coming in and all those things, as our capacity got increased, we could look into these problems and solve it. So basically today, what we are doing is, instead of keyword matching, we are passing the whole code. LLMs have the capability to understand the code, understand what it's doing, and then cater to the user question, like write new code on top of it, add a new functionality, or like find a bug in the code, right? Anything it can do, and most probably it can do generation because it can understand the context of the code, right? So that, let's move on to the next part, right? So why it became possible was because of this because of this mechanism called attention which came in, right? So what does attention do is, attention is what lets a model look at one word in your code and instantly know which other words around it matter the most for understanding it. Okay, so it will look at one word of your code, and then it will try to have a semantic understanding of what's going into the code, right? Before attention, machines were just matching characters. After attention, machines started reading meaning of words. Okay, so now look at this code, like very, very small piece of code, right? Total is 0 for price in prices. Total is equal to price, print total. So we are just printing total, looping over prices, and then assigning total a price. And now like, let's say, like, how do you understand the meaning of total over here, right? What is this total if I say, right? How will you understand? So if I say print total, how will you understand, right? You look around the whole code, right? If you have to infer the meaning of this total, you have to look around the whole code, right? The context of it. You will go line by line of the code, understand its meaning, then you know, okay, what I'm trying to do over here, right? In this particular print total example, right? So the same mechanism now machine can also do, right? What it will do is, when I give it this piece of code, and let's say if I post in a question, why does this print only the last price instead of the sum, right? So see, this is a bug in the code, and I'm asking this question. I'll post this completely into an LLM, this whole thing. I'll give this code and ask it this question: why does it print only the last price instead of the sum, right? I mean, it's very easy for us to figure that out. It's pretty easy. But let's see step by step what and how an LLM will answer this question, right? So this is the user input. Like, we go into ChatGPT or some other model, and we go in and put this input, right? Then let's see step by step what does the model do to answer us, like what's going wrong over here. How will it get an understanding of this? How will it understand what is the user question, and how will it give you the answer? So we'll take a look into that. Okay. So the model, first step, the model takes this whole thing, code plus your question, and runs it through 5 steps. Each step is a transformation. By the end of it, it produces an answer. Okay. Now let's look at those steps, right? So first step is tokenization, which is turning text into number pieces. Hey, Manoj, do you have a question?
No, no, no.
Okay, cool. So the first step that the model does is, which is called tokenization. Now we all know that computers, like, they don't understand words, right? That is for sure. They can do keyword matching, but they don't understand words at all, right? Any processing in computer is a math or a binary operation. They don't understand human language, right? So first, what will we do is, through tokenization, convert words or text into numbers, right? Numbers which the computer can understand. The model cannot read text; it can only do math on numbers. So before anything else, your input gets chopped into tokens, right? What we want to do is, inputs, we want to break it into tokens, small pieces of text from a fixed vocabulary. I'll tell you what this fixed vocabulary is. But if we need to imagine, it's like this was our input, right? Total, see this piece of code and this question, this was our input. Now what the model will do is break them into tokens, right? So total will be assigned one number, equal to will be assigned one number, zero will be assigned one number, and this is the new line character. This will even be assigned one number. For loop, for will be assigned a number. Price will be assigned a number, right? So basically what we are doing is breaking the whole sentence into individual words and then assigning them a number. We look at how these numbers come up, but think of it like, right now we are tokenizing it so that the machine can understand the numbers, right? We have converted into some numbers over here, right? The model still understands nothing. They are just serial numbers. Okay. Now, after we have these numbers, right, what we will do is, we call it embedding or vectorization. Okay, what is vectorization? So now what the model will do is, the serial number 14436 which we took above, right? This is just a number. How does it convey the meaning of the word total, right? We don't know that. I mean, how will the machine even know that 14436? What does it mean, right? Or what does it represent? There has to be something, right? We just converted this. We converted this text into this particular number, but we don't know what these numbers mean, right? So now what will happen is these text, like these numbers which we got, right? They will be converted into vectors. Okay. Now think of it like this. Like you can think of it like this, like there will be a table, okay, which the model will already build, where what it will have is word to number mapping. We use hash maps and all, right? So think of it like this only, right? Where what will have, if I have these words, right? The sky is blue, or the sentences or the code that we have, each of the word in my sentence or the code will have a mapping. Let's say 436, 729, 1000, something like that, whatever I took, and then 20, right? So what it will do is first it will, so when it took the input sentence, what it did was it looked up each word in this particular table and assigned it a number. Okay. Now in the next step, I told we do vectorization. So what does vectorization do? There is another table wherein like you will have, it's a very big table. So it will have this mapping of numbers to vectors. Like for example, like 436 will be a vector over here with some values. Like these are called with some dimensions. I will get into like what these dimension means and all. But right now think of it like this number is mapping to a vector, right? So I got the sky. First, I converted into a number. Then this number will map to a vector. So this is already pre-built by the LLM, right? So 729 is a vector, 2, 3, 4, 5, something like this. And 1000, let's say this is, then this will also get converted into a number, something like this, which is like vectors. So first we converted into numbers, and then from numbers, we are converting into a vector, right? And this is pre-built by the model, right? It's not done on the fly or during the training. It already does build this tables, right? So now we understand that it converted into numbers, then into vectors. Now, but what actually is vectors, right? These were English words. I converted into some numbers, and then now I'm telling that it is converted into vectors, right? What is even vectors, right? What does it mean? Okay. So let's look at how the meaning of the word is converted into a vector, right? Let's take an example of like a 2D space, right? Let's say if you have x-axis and y-axis, right? So if you had a point in this space, right? So 1, 2, 3, right? 1, 2, 3, right? So if I have to represent a point around x and y axis, what would it be? 2, 2, right? So this would, you can consider this as a vector, right? If I have to represent a point in a 2D space, right? Similarly, if I have to represent in a 3D space where x, y, z axis is there, suppose a point is there, what will I do? 2, 3, 4. This will be a vector, right? Something like this. A point is represented in a space like this, right? So now we are looking in, why I'm giving this example is vectors look something like this only, right? This 0.9, 0. These numbers are there, right? So they are points in a n-dimensional space, right? So what are they? So now if we look at the word, this thing, right? Total. What is the English meaning of this particular word? Total, what does it mean in English, right? It could be the as a whole amount, right? Commonly, and it could also be like, it's a commonly reused as a code variable name, right? So in English, total means sum of something, right? Or and it's commonly used as a code variable name. So if I have to represent this total thing as a vector, right? So what I will do is like what the model will do is it will have something like this. It will have different axes, right? One is noun, the other is aggregate. Okay. The other is like, does it represent a quantity and all? And in total, like ChatGPT and all, they have around 13,000 accesses. Okay. Okay. So what it will do is now I want to convert this word total into a number. So what it will do is it will try to break it down into a way that represents the meaning of total, right? So whether it's a noun or not. So if let's say total is represented by this point over here, which I'm pointing. So what it will have is like in with respect to a noun, is it a noun or not? So it has a 0.9 over there, right? Does it mean an aggregate or sum? Along this axis, it will be a 0.9. Does it represent a quantity or not is one axis, and the value on that axis is 0.8. Typical variable, is it a typical variable name, is also an axis, and along if I and this point in that axis is 0.5. and whether it follows an sum pattern or accumulator pattern or not is an axis, and along that axis it's 0.7. So you can see the analogy, right, where like how we were representing a point in xy axis, similarly a vector for total is something same. Only these axes are created by model, and the model does it by itself. Nobody hard codes it, or there is no fixed axis. But what we are doing is total is represented. You can think of it is like breaking the word total into some common words which can represent its meaning, right? How is it is it a noun or not? Is it an aggregate? You can think of it as a profile for the word total, right? Similarly, if I have to represent the word price, what does it mean in English, right? Generally, price is a money word, right? Or forget about this part, just in English, it means a money word, right? So now if I have to represent price in terms of a vector, then how will I represent it? Again, I will check like these examples have this same word, like whether it's a noun or not, whether it's related to money or commerce or not. Is it a single item value or a multiple item value, whether it's a countable thing or not, whether it's a variable name or not. So these are just imaginary axes. Think of it like the word will be represented in terms of these values. Okay. So now again, if I have to represent the word price, the vector for it will be a point in this n-dimensional space. Okay, it's hard to show an n-dimensional space, and these are this point will be along, and these will be the axes. Okay. Is it making sense or any doubt over here? Like I said, this is an imagination heavy class, so you have to imagine a little bit that what am I trying to say over here, and you have to understand this fact that see, I am trying to convert English words which the computer does not understand into math, right? Something which the computer understands, right? So this is how I can represent. Similarly, this gives you a basic idea, right? So similarly, if I have to, I'm taking all the examples from this code, right, which we have taken over here, right? So how is it first it converted into numbers, then into vectors? But what do these vectors mean is what we are discussing right now. So we saw the vector of price. It will be, so I showed it, right? What does 0.9, 0.9585 means? So price vector will look something like this, 0.9, 0.95, looks as a tuple, 0.85, 0.8, 0.7. Okay. So now see how this math is representing this word, right? And how we have broken it down, right? So that it represents the same number, right? Similarly, prices will be same to price. The only thing which can change over here is it's whether it's a singular or a plural axis, the value of price will change along that axis. And whether, since prices is like something which is multiple, right? So whether it's an iterable thing or not, the value will change along its axis, right? So price can be represented as this vector. Okay. Similarly, for loop, for the for in the for loop, what does it mean in English, right? It could mean different things in English. But for example, let's say a Python keyword, a loop construct is its meaning, right? In terms of programming, and in English, it could be something else as well. Like for can mean anything. So the accesses for it can have English terms or can have like programmatic terms. Is like I said, right? The total accesses that GPT works on is 13,000, right? So here I'm only just showing 5 accesses. So for the English word, it will be a combination of these code related accesses plus some accesses which are related to English. They will also be there, right? So for it will be a Python keyword. So Python keyword, there is an access. Then whether it's a loop iteration or not is an access. And whether it's a control flow statement or not is an access. And then for is a point along these accesses, right? Similar to X, Y, Z, like how we represented a point in a 3-dimensional space. So here just the dimensions change, but we are representing an English word with respect to these dimensions. And these dimensions are created by the model itself. That is what we are trying to say over here. It's imagination heavy. Just try to imagine it right now. Okay. There's nothing to like learn, but I mean to memorize, but try to understand the concept, like visualize the concept that how is it trying to uh, convert a word into a mathematical expression, a vector, via first it converted to number, then into a vector. Similar for equal to, right, which we had in the code, it will convert it into a vector along these axes: assignment operation, mutation, single character operator, overrides, accumulator pattern. Print, similarly, it will convert it into an point over here, right? Which the axis for which is whether it's a function, is it callable or not, output, whether it's an input output IO, side effect, debugging tool associated or not, right? So now think of one more point is like what vectorization does is like I have these accesses and then it maps all these words in those accesses, right? So what happens is like, see, the words which have similar meaning, right? They form a cluster over here in those accesses, like prices and price will be very close to each other in that n-dimensional vector space, right? For loop and while loop, like they will be very close together in this n-dimensional space. And then print and console, right? Which we had in our code, like print is used in Python and console is used in JavaScript, right? So they will be very closely clustered. Their vector will be very close to each other. So all these points which I'm trying to show are vectors in the n-dimensional vector space, right? So their vectors will be very close to each other. Now, see, one important thing over here is in our program, right? Total, if we see, right? Total is coming at three places: total over here, and total over here, right? So when we convert it into vectors, right? Although they are at, different lines, but their vector will still be the same in the initial phase, right? All of them, the vector that represents them will be the same, right? So now, why are we converting it into a math, right? Why are we converting into numbers? Is because computer understands number, and now mathematics will be possible in this number. So what kind of mathematics? Imagine something like this. Like, let's say if you take the vector of king, right? And you take the vector of man, right? And if you take the vector of king and remove the vector of man from it and add the vector of woman, you will automatically get the vector of queen, right? So see how interesting it became. We took words, converted into numbers, then into vectors, and now we are doing mathematical operations on those numbers, right? So it's pretty interesting. You will get more hang of it as we go along. But you are able to visually understand, right? What is like vectorization? Because this will come up during RAG and all the other flows. It's a very important concept. Vectorization, embedding, they are interchangeably used. But what are we converting words into is very important, into vectors which convey their meaning on different axes. We are breaking it down in such a way. And why are we breaking it down? So that we can do some mathematics on it, so that we can infer things from it, right? So, and the other thing which I showed was how it's using these two tables. First, I already have a table created where I will look up what is the word the means, right? So I will get 436. I have another table where I have a mapping of this number with this. I have the mapping of sky with this number. So it will, when I give an input sentence, it will just look up this table and give me the number. When I do vectorization, again, I will take this number and see another table which has the vector defined for it. Okay, so this is how it's working, like tokenization and vectorization. Okay, now we have converted it into a converted word into vectors which somehow have the meaning of the word in it, right? It's very loosely coupled, but it understands what is the meaning of that word, right? We how via these accesses, right? That should be clear by now. Okay. And you can also, I can take an example, right, which can be easy to understand is, so there are different colors, right, in the world. And in computer science, what do we do is every color can be represented using RGB profile, right? You might have worked on it, right? For red, there is an RGB profile 0.1. What is it along the red axis? Like not for red is already present over here. Like let's say for magenta, right? So what do we do? How do we represent magenta using the RGB axis, RGB color profile, right? We tell it what is it in terms of red axis, right? 0.1. What is it along the green axis? 9.2. What is it along the blue axis? Maybe 5, right? So magenta has a color profile like this, right? You might have come across this, right? So similarly, think of vectorization as similar to this, right? I can represent a color along these axes, right? Similarly, I can represent a word or a meaning of word along different axes is what vectorization does, right? Now let's come to the next part, which is positional encoding. Till now, what we have done, we have vectorized, we have tokenized, and we have vectorized. Okay, but the next example which comes is positional. What do we do? Because still we know how can I represent a word in terms of a mathematical expression. But let's take an example. If I write this I have to understand the semantic meaning of the sentence that I'm writing, right? So if I write a sentence right now, total is equal to price and price is equal to total. Will the computer be able to identify that they are two different things? On the first line, I am assigning total price, And on the other second line, I'm assigning price to total, right? So during our tokenization and vectorization process, right? So the vector for all of the three will be the same, right? Total will come up from the table. It will have the same vector. Equal to might have the same vector, right? And price will have the same vector, right? So till now, till the process that we have done, our end goal is to understand the whole code, the semantic meaning of the code, right? So that I can help with the user query. But in my process of tokenization and vectorization, still I cannot differentiate between total is equal to price and price is equal to total, right? This is just an example, right? Because the vector for total in this case will be picked up from a table which has the same, which could be same, equal to will be same, and price will also be the same thing, right? So I can't differentiate between these two statements, correct, right? So because their position also matters, right? Total is at a different position and price is at a different position over here. And in the second sentence, price is at a different position and total is at a different position. So in order to have a semantic understanding of sentences, we need to take into account their positions also, right? So this is what positional encoding will do. So what it means is, like, we have the vector of total, right? So what I will do is I will add something to it which says that, okay, total is at position 1. Similarly to the our program was this, right? Over here, our program was this. So what I will do is I will, to the first total, I will take its embedding, which is the vector, and add something to it, like let's say 001 or something, so that I know that total is at position 1 in my question or in my sentence. Similarly, for 2, I will take the embedding of 2, which is the vector, and add this thing that I am at position 2, right? 0, I'll take the embedding and I am at position 3. I will add something, add some vector over there, right? Why do we need to add positions? We understand, right? In different sentences can mean different, and the position of words are also important. I will take one more example which will help you appreciate that why positional encoding is important, right? Let's say I have two English sentences: the dog bit the man and the man bit the dog, right? Here what is happening? Dog bit the man, right? Here what is happening? The man bit the dog. But if I look up my vectorization table, right, all the vectors for this will be exactly the same in this sentence versus this sentence, right? Because they are hard coded in the table, right? So how will I infer the meaning of this versus this? I can go wrong, right? Because they are fundamentally different. But so I need to consider what is the position of dog over here in this sentence, what is the position of dog over here in this sentence, because that will impact the meaning of the sentence, right? So that is what positional encoding does, is nothing. If you have picked up a vector, like for dog, you picked up some vector 0, 1, 2 from the embeddings table, right? So it will add a position thing also over here, that, hey, dog in my sentence is at position 2, right? So it will add some value like 0, 1, 1 or something to it, so that now the vector of dog will encapsulate this information also, that what is the position at which the dog is, which will help me answer this question later, right? So we did tokenization. It is pretty clear, easy, converting it into a number. We did vectorization. We converted into the word into an n-dimensional space which has some meaning. The word has some English meaning, and we are splitting it into axes which convey the same meaning. And then we added positional encoding. Okay. So what it means is, like, to answer the question, I also need to know the position of each word, in the sentence, because it matters, right? To understand the semantic meaning of the sentence. Now let's come to the most important part, which is like attention, right? So see, like in the first, this is our code, right? In the first sentence, in the first example which we took, what did I say? If I have to understand the what total is over here, I have to look at the surrounding context, right? What is total doing above? If I have to understand the meaning of prices, I have to look at the surrounding context, right? What is prices? I have for, price, in, right? So to understand the meaning of prices, I have to look around that, hey, what is it doing? In order to understand this code, what do? We actually look around the whole code, right? And then we can understand, derive meaning from it, right? So attention is nothing but but at this point, before attention, what the model has is, it understands what each word generally is, right? We have a general meaning of the word, but in this context, what does it mean, right? Total in this context, in the programming context, is different. In an English sentence, it's different, right? So attention, what it will do is, it will look at your surrounding context, the other words or other sentences around it, and then it will enhance the meaning of the total, right? That what does total mean in this context, right? So think now, imagine some more, right? How we are logically solving the problem, right? Like humans, we are training the machine also to logically look around the things and try to understand the meaning of each word in the given context, right? So during attention, what happens is each word take a look at other words around me and then updates the word's meaning to reflect the answer, right? So what it is doing is it's looking around all of the words around it and updating itself so that it can grab the context or understand what's going on, right? Let's take an example. Let's take this code example, that what will happen after attention, right? So let's see total on line 1, right? Before attention, what it is? I am the word total, I generally mean sum, right? This came from vectorization, right? I converted into a vector. That vector just can tell me this, a general meaning, that I can generally mean a sum, I am a word total, right? Now what attention will do? And like I said, we will see what is the mathematics or how will attention work programmatically. But this is on a high level, that what happens during attention. So attention looks around and sees there's a equal to next to me, right? So in total, when you give this input, it will look at 0, this equal to, that is around me, right? And 0 after that, right? So initial meaning was I am the word total, I generally mean sum. After attention, it will turn to I am total, I am being set to 0, and I am being initialized. Okay. So attention will help it convert like this. Okay. Now total on line 3, which is total is equal to price, right? Over here. Now, see how the meaning of total will change over here. Before attention, again, it's the same, right? I am the word, I generally mean a sum, same as above. This came from vectorization layer, right? Because I looked up the vector for total and it was the same. I got the same thing. Now attention will look around it, right? See how attention changed the meaning of this total. See how it will change the meaning of this total. It will look what is around me. I have equal to, I have price, and I also have above things like for price, in price, and total is equal to 0. So it will take all this into consideration, and then it will change the vector of this total, right? And change it to something like this. There's a equal to next to me, price after that, there's a loop, for loop above me. I am inside the loop body. So after attention, I am total, I am being overridden with price on every iteration on the loop. See, this is important. That is what is happening in the code, right? Total is equal to price. So now the vector of total will change how I am total, I am being overridden with price on every iteration of the loop, right? So this is what will happen for each of the word over here, equal to this thing. I'll come back to this again, but I think visually it's not making sense. So I want to show you visually what will happen, right? So now let's come back to our original example, like how will this change the meaning in the vector space, right? So let's say this is our vector space, okay? Now there is the word total. Our program had first line had total is equal to 0, right? So let's example this point is over here, which has this vector, right? -2 and 2, right? I need to know what is the meaning of this total. So what I will do is I will look at the words around me, which is equal to 0, right? Equal to and 0. So what I will do is now I will take the vector of this and do some mathematical operations using the vectors of equal to and 0. So how total will move is, like, let's say total initially was here. I first I took the vector of equal to and let's say multiplied it with my original vector, which is 2 cross 2. And then after multiplication, what it will move is this vector will move into the assignment space. Okay, that hey, some assignment is being happening. Now I take the next vector, which is 0, right? And I multiply the vector of total, which was already multiplied with the vector of assignment, and then it will move the vector to another space, which is like assignment initialization space, right? So see how mathematically we are taking numbers, multiplying them, and the meaning of them is also changing, right? So what I need to do over here is I am updating this vector itself, like the initial vector, which was 2 cross 2. I'm changing its meaning by looking at the context around myself and updating the vectors by doing some mathematical operations, right? So what will be the final result? So I have a vector of total. So when I multiply it by the vector of equal to, I will get a nudge, right? It will move towards a nudge from the vector assigned, like vector of assignment, it will move the vector. Then I will multiply it vector by 0, then it will move it along different direction, right? So let me show you a better example. It will be better. I think it's hard to do. So let's say total is some point over here in vector space, which is 2 comma 2. What did attention do? I want to absorb the meaning of the sentences around me, right? So it will take the vector of, let's say, equal to, right? So my initial vector was 2 cross 2. I will multiply it, right, with the vector of equal to. Now what will happen is this point or this vector will slowly move towards the assignment space, right? Because I used, so this 2 cross 2 will be modified to something maybe like from minus x, right? It moved to plus x. So right after this multiplication, it will move over here. Then I will multiply it by equal to, and this vector will move somewhere over here. Okay, so see how mathematically it has observed, or like it has taken the context around of the words around itself and updated itself, right? This is again a very important concept. I'll take a pause over here and see if there are any questions. Manoj, are you able to understand this? Like,
Yes,
what's
yes.
yeah?
Yeah.
Okay. So this was for the first total. See how the first total moved in my sentence, right? Total is equal to 0 was there. So I have updated the vector of total, right? Attention takes the surrounding context and updates itself, right? So that I can semantically understand what its meaning is. So it's moving the vector between different vector spaces, right? Now let's look at what happens. So it will happen so this attention happens for every word, right? So every word in our input, which is like this program was there, right? Total is equal to 0 for price in prices, total is equal to price. We have broken down each word into tokens and then vectors. So attention also happens for each word. Okay. What does attention mean? Is I have a generic meaning, but I want to understand in this particular context, what do I mean? I have to absorb some context from the surrounding areas, right? So this total will look at its surrounding equal to 0 for print, all of this. And it will say, hey, my meaning is generally impacted by these two words, equal to and 0. So let me absorb this meaning. So mathematically, how am I absorbing this meaning is, like I said, I had, let's say, assignment was some cluster over here, 0 was some cluster over here. I mean, initialization was a cluster over here. I just want to explain this once more, guys, so that it's very clear. So total was something over here. Now see, assignment is a cluster which is already built, right? And initialization is one more cluster which is already there, right? So total is equal to 0. I mean, we can look at it and understand easily that it is doing some initialization. But see how the meaning of total is being updated over here. We took total, we multiplied it with the vector of equal to. Once I multiplied it with the vector of equal to, this total vector got updated and moved towards this space, right? So see, this vector is now containing having some understanding of this space. Now I again multiplied this whole thing with the vector of 0. So this, my initial vector of total, now moved along this, right? Initialization, right? It will somewhere be close to initialization. So see how we are taking the vectors of each of the words and encapsulating meaning over there, okay? So this is what attention will do. Now let's take one more example. That total, my program was this total is equal to 0 for price in prices. Now let's look at this total. How will it get updated, right? Over here, this total should look at all the surrounding context, right? So it should look at this. It should look at this. It should look at not this part, but the above ones are shaping it. So it should look at only the above code, right? Because that is what is shaping it, right? So how will the vector of total get updated, right? So initially, let's say the total vector is somewhere over here, right? Which is again at the start, like I said, right? Initially, all the three totals will be at the same place, right? Because we have looked up from the vector table, right? I told that part, right? All initial vectors will be at this particular position itself initially. So we saw how this vector changed and absorbed meaning. Now let's look at, I'm calling it L3 total, right? Let's see how will its meaning change. So we'll take this vector. Now it will again multiply itself with the assignment operator. So initially this vector will become, let's say it was 2 comma 2, it became 3 comma 4. So now it is in the assignment space, right? Now after this, if I again, what I will do is I will take the vector of price and multiply or do some mathematics on it on this vector, and then it will move towards this space, right? Because if you see, the price vector was already over here, total is equal to price, right? So I took this vector and multiplied with the vector of price. So it will push it towards this vector. Okay. So this is how the meaning will be encapsulated over here in all the vectors, right? So what does it say? Strongest things around me are equal to and total. I will multiply myself with these two vectors and see how it moves. Okay. So this is what. And like I said, total from line 1 will also have an impact, but minimal. We'll take into look into this, like how do we decide that which words will have more impact versus which words will have less impact, right? Loop will also have an impact, but minimal. In the accumulation axis, it has moved towards single value overwritten. This is an important point. We didn't talk about this. So what does it mean is, like, let's say there is an accumulation axis. What does it accumulation axis means? That let's say it means that we sum up some things, right? So sum will, if I have to represent something along accumulation axis, sum will be very high over here, right? So since accumulation is in the y-axis, so sum will be somewhere top on it. So total initially with the vector, it was somewhere high in this space, okay? But after we multiplied it with equal to and price, it moved to low along this axis. So if it was like initially 2, 2, now see how the value of y-axis reduced and it became 4, 1 or 0.5 maybe. So in this axis, it became less, right? Why? Because total is assigned something, a price over here. A single value is being assigned over here. It's not kind of doing an accumulation. So this is how it's absorbing the meaning of the words, right? So now let's look at what happens on to the total on line 4. Okay. So this, our program was something like this. Now let's see how this total will get updated, right? So now this total has to absorb the context of the whole program, right? It has to take into account this total. It has to take into account this total and absorb its meaning from the surrounding context. Now, how will it do? Like I said, right? Again, I'll take the accumulation axis as an example. Let's say accumulation is an axis, right? And our all the three totals were initially over here, because by the general vector, it I mean, if I take the look at the table, generally it means a sum, right? So all the three vectors were over here. We saw how L1 and L3 moved, right? Now let's see how L4 will move, right? So what will happen is we look at the total at this. So around this, what is the first thing which will have more impact? Print, right? So let's say print console, like I showed in my initial thing, right? Or something over here. So this total vector will multiply itself with the vector of print. After doing that, it will move somewhere down over here in this particular axis. Then what it will see is, hey, print had an impact, but this total price and this for loop also has an impact on me, right? So what it will do is, it will then multiply it with that vector, like the other vector, and then it will move towards this particular thing, right? Because we had seen initial, I mean, I hope you are able to mentally map that I took the total of L4, multiplied it with the vector of print, and I moved over here from here to here. And then when I multiply it with a vector of line 3, then it will automatically move over here, right? Which means that no accumulation is happening over here, right? I'm a singular value, because it's down. The value is very less along the accumulation axis, right? So what does it mean? Total L4 no longer means a running total being printed. It now means a value being printed that isn't actually accumulating anything, just the last price assigned, right? So it will absorb the meaning from the surrounding context. Now, just see what we have done. Question 1 is like, where does the word total by its name want to live, right? When we started, where were all the three totals living? Over here, right? Which were high on the sum axis. Like, think of it as sum. Like, this axis represents that a value which is doing sum should be very high on this axis, right? So initially, all the three totals were over here. Now, after our update, where did total L4 actually end up after attention? Here, right? Which means that it became very low. Which means, what does it actually mean, right? This total word had to mean sum, but somehow it became very low, right? By multiplying it with its surrounding context, because, and then it will try to infer that, okay, this is the bug, which is, I mean, the concept geometrically, if you see at it, right? There is a anomaly over here. The mismatch is the bug. The geometry now contains a contradiction. The word is named like an accumulator, total, but it behaves like an overwriter, right? So what was the bug? What was the initial question I was asking is like, why is my total printing the last price? Because I was doing an equal to over here, right? So geometrically, see how when we are doing attention, it is moving towards the right answer. That because you multiplied it with like surrounding context, it's like going wrong in this way. Okay. So what will be the output of the attention layer is, we have all the original vectors. Let's take an example, total of L1, which was originally 2, 3. Now we multiply it with other vectors or the surrounding context, and all the meaning is absorbed over here, right? It became 5, 6 because it got multiplied with other vectors, and then 5, 6 came in. We absorb the context from the surrounding environment, right? This is like attention. And this will happen with all the words. Like they will look at their surrounding environments, multiply them with each of themselves so that they can absorb the context of the surrounding environment. Yep. So I'll take a pause over here. I mean, is it clear? I know it's new and maybe, yeah, this was hard to imagine, but is it making sense, or should I explain it once more?
No, making sense. Just trying to understand. Okay.
Okay. But it's making some sense, right, Manoj? What
Yes,
it's
yes.
trying to do is it's trying to absorb the meaning of the sentences to answer the question, right? Mathematically, we are trying to multiply things, add certain things so that we come into the same vector space, right? One
Yes.
example which I will take, which can make things a little bit clear, is this. So initially, what we said was, if we have a vector of king minus man plus woman, right? It will give you queen, right? We discussed this, right? So now let's think of it at there is a gender axis. So in this side, there is male, and like plus x minus x is there, right? So similarly, if this side is male, this side will be female. Okay. And uh, uh, and this y-axis, what it is? Royal, not royal, general, right? If this is royal, plus y is royal, then minus y will be opposite of it, right? So it will be general or something, right? So if I have to represent a point which is king, right? A king, what it is? It's a man, right? So along this axis, it will have some value, and along royal axis also it will have some value. So king can be somewhere over here, right? Right. So king is something over here, a point over here. Minus man, right? So minus man, if I do, I mean, this is the gender axis, right? So if I do minus man, what do I mean is, like, if this was plus one along this axis, right? I want to make it as I am doing a minus man, so I'm removing this component. So if it was initially 1, 3, I am removing this gender or the man, whatever it was getting along the male axis. If I'm removing this, what does this point become? 0, 3, right? So where does it, what does the word got updated to? Is just royal right now. It does not have any meaning. So I took the vector of king and removed man from it, right? So the vector now lies over here, which is just the royal axis. Now I do a plus woman, right? So what does it mean is, like, I will move somewhere around this axis, because this was male axis, this was female axis. So if I do a plus woman, it will start coming something towards this, right? And if you think initially, queen is something like royal and female, right? So queen was somewhere over here itself, right? If forget about this part, if I was representing queen, it was royal plus female, so it might be over here somewhere, right, along this axis. Now see how this vector is changing. I took the vector of king, I did a minus on man, so it moved to here. Then I did a plus of woman, which is like along this axis, I should move somewhere, right? So I moved along this axis, and now it came close to a cluster which represents queen. Maybe this makes it clear that what vector map means. How does it transform values? Okay, so this was like what will happen after attention. Now let's move to the next part, which is like step 4, which is like the feed forward neural network. Okay. So, I mean, Manoj, should we pause over here, or let's go forward and complete, or do you want, because this is a heavy concept, you want to go and look at it once and
Yeah,
understand?
I want to go in look at first.
Okay,
Better to pass here for me.
Sure, sure. Yeah, yeah. Okay. I think it's already 2, so we'll take a pause over here. But today I'll just revise whatever we have talked about till now. We have looked at these 3 things at at a good level, that how are LLMs working? How did they broke the words that I have in my sentence into tokens? Then what is vectorization? What is positional encoding? And then what is attention? So what we will do tomorrow is we will revise all of these 3 again, and then move to feed forward neural network and how it's predicting the output. Okay. So I'll stop the meeting today over here itself. Like, go in and then revise whatever I have talked about till now, and then we'll continue tomorrow from here.
Sure. Thank you.
Thank you, guys. Bye.